Hi and welcome to iLecture Online. In this segment, in this set of videos, we're going to talk about Newton's laws of motion. And of course, we'll start with number one, our first law. And as we go through these videos, we'll look at the three laws of motion and then how the laws of motion are applied in physics and how we need to look at mechanics problems in the light of the understanding of the laws of motion in order to be able to understand how we need to be able to solve them and how we follow the train of thought and the logic in how we solve these kind of mechanics problems. So understanding the laws of motion is a very important thing. So let's start with the first one. The first one states, and this is a little bit paraphrased, an object once in motion will remain in motion along a straight path at constant speed forever. So what we're saying here is that once an object is in motion, it will continue in motion in the same straight path at the same constant speed forever and ever and ever. Now that's a strange concept because in normal life that doesn't happen. In normal life we kick a soccer ball and it eventually stops. We throw a football and it goes in an arc and eventually it stops, bounces maybe on the ground, doesn't go any further. Cars, once you take your foot off the gas, they begin to slow down and they stop. So it's not something we are used to in normal life. So it was kind of interesting how Newton came up with that idea. Now it wasn't his personally that for the first time he came up with it, but he kind of set it in a light where we had never done before. And so he knew that in the absence of any interfering forces, an object would just continue moving and moving and moving. And of course, he started looking through telescopes at the heavens, at the planets and the stars. And he realized that away from any gravitational effect, that would indeed be the case. So it was very clairvoyant in a way. On top of that, he continued saying, and an object that is at rest, so if an object is not moving at all, just kind of sitting there, not moving, it will remain at rest forever. Again, forever. Nothing will ever change unless a force comes along that causes a change to that. So that was a very important factor in understanding motion. So as a simple example, if I have a cart sitting there with no velocity, it will just sit there forever and ever and ever. It can come back in 100 years. It's still there, hasn't moved. And if an object like this cart is moving at some constant velocity, it will just continue to do that unless some force changes that. And of course, normal life, there's friction, there's wind resistance, and those kind of things tend to slow things down and stop them. But if you can imagine in a pure world where there's no friction, no wind resistance, nothing like that, of course, that's only exists in physics books, then yes, this object would just continue forever. And of course, in space, away from gravitational forces, that is indeed the case. So let's say we have a rocket. The engines are going, the rocket is accelerating because of the force applied to the rocket with the engines, but as soon as we shut the engines off, the acceleration stops and the velocity will remain constant. The rocket will just continue going in a straight line unless there's some planet nearby that pulls it off gravitationally. And so Newton also realized that, for example, the moon is circling the Earth, and it does that because there's this constant gravitational force pulling the moon inward. He said if that wasn't the case, if for some reason the gravitational force would instantaneously stop, the moon would just then continue, according to his law, in a straight line path forever and would no longer circle the Earth. So that's the concept of Newton's first law, is the idea that unless there's a force acting on an object, the object will just continue in a straight line path, no force required to keep it moving, and if an object is at rest, it will stay there forever until some force comes along to get it to move. So that's Newton's first law.